This is Scott. I'm the forecaster for NEPA Storm Chasers, winter weather specialist. You've been watching my forecast now for a couple of years, but this is the first time we're actually filming a video, and we plan to do more of this in the future to help better educate and prepare people for the storms and situations up ahead. So, let's take a look. I'm going to show you our 2020-2021 winter weather forecast. We're going to be experiencing a La Nina event this year. It's already ongoing. La Nina, as most of you know, is just colder water temperatures, upwelling that occurs in sub-equatorial waters off of the coast of South America and into the Pacific Ocean. Typically during a La Nina pattern, you have wetter than normal temperatures in our area. Wetter than normal weather in our area and above normal temperatures, but that can go either way. It's usually drier in the south and wet in the Pacific Northwest. This is what a typical La Nina pattern looks like here. As you can see, the colder water stretching all the way out into the Pacific. This is what our La Nina currently looks like. This was about 10 days ago or so. But as you can see, we're clearly in a La Nina pattern. So, what can you expect when you have a La Nina? As you can see by this graphic here, it kind of gives you an idea of what's going on here. With the colder water temperatures here, it changes the pressure gradients, and you wind up with a high pressure that usually develops somewhere off the coast of California into the northeast Pacific Ocean. That leads to funneling of cold air down from Alaska and the Canadian Maritimes into the United States and eventually exiting out somewhere in the Northeast. It definitely brings colder weather to the central, north central United States and sometimes even the Northeast. So we'll figure that out when we get there. Let's get moving. So in a typical La Nina pattern, you have ridging in the west, troughing in the east, which is what leads to your wetter, below average temperatures in Washington and Oregon, Pacific Northwest states, and usually drier and warmer down to the south. As an active storm track sets up, as opposed to the La Nina or El Nino, where you have a less active storm track, usually a flat jet, which is what pipes in all that moisture to the southeast or southwest and across to the southeast. And you typically see a lot more warm weather as the low pressure sets up in the Gulf of Alaska, allowing high pressure to form, and pretty much the upper 2/3 of the U.S. during an El Nino event is usually warmer than average. So this La Nina should be interesting, to say the least. I got a couple of beliefs on why I think this is not going to be the driving pattern in this winter season, but we'll get into that in a second. The other factors you have to consider besides La Nina. These teleconnections are things we talk about all the time. The Arctic oscillation, otherwise known as the polar vortex, the NAO. You'll hear us talking about blocking a lot, the PNA and the EPO. Now, what do these mean and why are they important to you? We'll show that in a second here. So this is what they look like from a 500 millibar map up ahead. This is over the Arctic Circle. This is just showing you areas that have higher pressure and lower pressure. And by being able to tell what your teleconnections are doing, what those four different oscillations are, it can tell you a lot about what's happening and what's going to happen in the future. So the PNA, this is what a PNA looks like. In this case, it's negative. So as you can see, you have a negative over the ocean here. Anytime you see higher pressure, it's going to be negative. When you see negative pressure, it's going to be positive. So you're looking at a situation here where there's troughing in the west and ridging in the east. This is a negative PNA pattern. This is not what you want if you're a snow lover. A positive PNA pattern would be when you have ridging out west and troughing in the east. So we're going to have to keep an eye on the PNA and see which direction this goes. This winter, I do tend to believe that we're going to see a pattern more similar to this, as we're going to have maybe a little shunted south, but you're going to have a lot of ridging. And I think you're going to have some deep troughs forming with some other things that we'll talk about in a minute. We talk about the polar vortex quite a bit. You may have heard about this during the winter of 2013-14. 14. The polar vortex is a locked-in area of cold air and wind that surrounds the polar regions. When you have a strong polar vortex, strong and stable, as you see right here, it locks in cold air and doesn't allow it to get past this area and to infiltrate the country or the continent, because the jet stream pattern keeps it spinning fast and relatively circular along the pole. But when you have what's called a weaker polar vortex, when you have areas in the northern hemisphere that warm, they call it stratospheric warming. When you have stratospheric warming events, it's able to push the polar vortex farther south because it weakens it, kind of like unwinding a ball of yarn, and it's kind of able to to move around and spill around in different directions. Kind of like when you spin a top and the top starts to lose its rotation, it becomes wobbly. And what happens is you get these little waves that form and these little ripples in the polar vortex, which allows colder air to move south and gives you opportunities for snow. This is what a strong, fast polar vortex looks like. No waviness, cold air bottled up right around the poles. And this is what it looks like when you have a wavy polar vortex. It splits off, as you see here. Half of the polar vortex is over the Hudson Bay, the rest over Siberia. It has become weaker. You have some warming that's pushed north, and you have some waves that form along here, and this allows some of this colder air to spill down south and gives you the opportunity. At least sets the table for some. If you get some energy moving along here, you can have a storm develop. So if the polar vortex splits, you could be looking at something like this. This is during the 2013-14 cold outbreak. As you can see, almost every state except for California, parts of Florida, and parts of Arizona were below average. And the same thing happened in 2014-15, although it wasn't quite as deep. It was definitely just as pronounced, and if not even colder in a lot of regions. These were the coldest two winters we've seen in any winter since 1994. So just to give you an example, what will happen if the polar vortex does weaken become wavy at any point. Now we talk a lot about the NAO because this is what causes what we call blocking. Blocking is when high pressure sits somewhere between Greenland and Labrador. It could even be a little further to the west, but what it does is it sets up a blocking pattern where it doesn't allow for low pressures to move on and in a progressive style out to sea. It forces, because of the winds blowing back clockwise, it dams air up here, and it forces the low pressures to dig and wrap their way up here, which inverts this axis here. Now, what does that mean in plain words? It means it helps nor'easters form. It gives these lows an opportunity to deepen because there's a strong pressure gradient between high pressure and low pressure. And when you have something like that, lows have a chance to develop, move along the coast before they push themselves out. And eventually these high pressures lift off and allow the storms to pass. But it can cause an awful lot of snow, an awful lot of issues when you have a roadblock essentially set up here designed to trap this low and keep it from escaping. Another example here of blocking. These images were both from a couple weeks ago, just showing kind of what happens in these cases. In this case, you also have a strong ridge out west that allows the jet stream to dive all the way down to the Gulf of Mexico before whipping back up here. If we have a lot of blocking this year, which I suspect we will, you're going to have a lot of at least opportunities. Now, opportunities don't mean snow. They mean you're going to have a chance for snow. It means the atmosphere is set up. You still need precipitation. You still need to get disturbances to come along here. So that EPO and PNA become important because they're the two teleconnections that are going to send waves of energy off to the east. And if there is cold air in place and if there's blocking set up, you can have the recipes for a winter storm. The Madden Julian oscillation. We also talk about this a lot. This is essentially where the tropical forcing is taking place in the Pacific Ocean or Indian Ocean. So why does this matter? Well, it matters because where you have the most moisture along the intertropical convergence zone in the Pacific Ocean or Indian Ocean, it'll dictate the weather patterns in the northern hemisphere. And it does that in a very subtle way. And I'll show you that in a second. So when you're in these phases on the left, 7, 8, 1, 2, these are considered cold phases. When you're in a cold phase, you have a chance of snow, you have colder than average temperatures. When you've entered these warmer phases here, you're likely to be mild temperatures. If you do have precipitation, it'll be in the form of rain. You're much less likely to have a big snowstorm, if at all, during these warmer phases. So I'm going to show you right here. This is phases 1, 2, and 3. Now, phase 1 is a transitional phase. You go back and forth from 1. So 1 could be a snowy phase, or it could be coming out of a snowy phase into a much drier, warmer phase. So during a phase 2 or 3 typically of the MJO, you have a high pressure that forms because you have forcing occurring in the Indian Ocean. So most of your moisture is here. Your pressures are going to be lower. So your pressures will be higher. You're going to have some lift to the atmosphere, and the pressures will get higher in the east or in the western Pacific Ocean, Central Pacific, and then it'll allow low pressure to take hold in the western United States, which then causes ridging in the east. Ridging in the east is never good if you're looking for winter storms. It's always going to be a blowtorch pattern. You're always going to get water coming up from the tropical regions, air coming up from the tropical regions, and this is not a good setup if you want snow. This is a phase 4, 5, or 6 look when you have the strongest forcing is starting to move its way towards the continent here of South America. And in these phases, you push the high pressure a little bit farther to the east and the troughing a little more to the central U.S., but you're going to see a storm track that's not going to be favorable for the Northeast. In fact, you're going to see a lot of storms that cut into the Great Lakes here. You'll be on the rainy side of storms, and sometimes they'll just completely miss, and you'll be totally dry. Also, the high pressure is going to be rotating clockwise and pulling water in from the warmer oceans, causing the temperatures to be a lot warmer. This is the phase you want if you want snow. You're looking at 7, 8, and then the beginnings of phase 1, and to some extent stage 2. You have most of your forcing take place off the coast here of South America. So your pressures are going to be higher as you have lift here in the atmosphere near the Rocky Mountain regions. And then you'll see troughs that will generally dig into the plains, sometimes all the way to the Gulf Coast and on out. Now this is what you want. This is the setup here as far as the MJO is concerned that makes your pattern favorable for winter storms. And this is a look at the Madden Julian oscillation. This is just like departures from normal as far as temperatures in these different phases. Over here, the ones I have circled, 7, 8, and 1 are your cooler phases, and 2 to some extent is a little bit cooler. This is more like an average phase. Then you have your 3, 4, 5, and 6 here. Those are all warmer phases. Those are very unlikely for storms, especially for winter storms to form. The QBO, this is the quasi-biennial oscillation, which is essentially the direction of the winds, which switches every 20 months or so at the equator. The only importance this really has, and it's probably of small importance in a lot of ways, especially compared to these other more fickle, quicker changing patterns, is the QBO. When you have a positive phase of the QBO, which is a westerly equatorial wind direction, you tend to have more mild winters. With your negative phases tend to incorporate more tropical forcing and better outcomes as far as snow. But I wouldn't put too much stock into the QBO right now. Sometimes the polar vortex follows the QBO and it forms a strong, as you can see, strong, confined, well-wrapped vortex. However, this isn't always the case, and sometimes this vortex can lean towards one or the other, whether it's northern Canada or Siberia. So more on that in a second. During a North American leaning polar vortex, even a strong one like we see right here, it has become a little bit elongated. Because it's become elongated, it's pulled some of this polar air down because, as you know, wind comes counterclockwise around a low pressure. So you're allowed to get this, what's called a cross-polar flow, You're getting winds directly in from Siberia coming all the way across the continent, and it can lead to really cold weather in the Northeast, even even when you have a strong polar vortex. This is an analog of all the years we have El Nino or La Nina conditions noted, and on the right hand side you can see I have in yellow the two seasons out of these 11 moderate to strong seasons that we had above average snowfall. So 2 out of 11 doesn't give you a very good chance. Both these seasons were very snowy. In fact, the 95-96 season was the snowiest season on record. So there is still that possibility of having very snowy seasons with a La Nina. It's just less likely. Now, our official forecast that I put out here about a week and a half ago or so, a week ago, and I made this forecast around 2 weeks ago, right around Thanksgiving. I just didn't have a chance to post it yet. But as you can see, I have much higher than average temperatures for the Southwest, with above average temperatures for basically the entire West, all the way through Texas and Louisiana, Pacific Northwest included. The center of the country, Midwest and Mid-Atlantic region and Northeast, I have average to slightly below average because I do believe you're going to see a jet stream set up somewhere in this white area here. Depending on how far north or south that jet stream is will determine how much cold air will be in play in this early part of the winter. The Great Lakes I do think are going to be below average, as I do think you will have a strong Arctic jet, and I think this area is also going to probably see above average snowfall. Now let's get on to the second half of the winter, where I think the La Nina begins to weaken. Temperatures begin to normalize around in the Pacific waters, and I think you're going to see this pattern shift just a little bit. And I think instead of seeing some of the deep troughing that we saw earlier in the winter, you're going to see a little more neutral pattern. I still think it'll be very active. You'll see a lot of storms coming in. The Southwest still above average, too much above average, depending, but I think you're going to see your storm tracks shunt a little further south, and I think that'll open up the opportunity for more snowstorms in the Northeast, especially if there is blocking setting up, which I do believe is going to be a reoccurring theme throughout this year, which tells me that we're going to have more opportunities at least for some bigger snows. Now, I put this out, again, about 10 days back, and I have for our region above average precip, but ice and rain more likely, less snow. Now, that's not less snow than last year. That means less snow than a typical season we could expect, because I do think we're going to be on the warmer side of a lot of these storms, or at least on the borderline. Now, on the borderline, there is an old expression that says, if to get the deepest snow is when you can smell the rain. Something along those lines. I butchered that pretty badly, but the point of that is the closer you are to the convergence zone, the more likely you are to get higher accumulations of snow. So I do think we're going to be on that borderline most of this year, and depending on blocking, that's going to be the number one factor I think that's going to determine a lot of this here. What does that polar vortex do, and are we going to have this blocking remain in place? Because the active storm track is going to give us opportunities. It's a matter of, are we going to have cold air in place? And the NAO, that negative NAO, the blocking formation, and that polar vortex are going to dictate the cold air, and if we're going to get enough of it to make this season better than last. But let's take a look at what I've come up with for the season. I think there's a high probability for both above normal precip, above normal snowfall, as opposed to last year, and a more active storm track. I don't think we're going to have above normal snowfall based on a regular season, but I do think we're going to see above normal overall precipitation. So if that does fall in the form of snow, then it could be a pretty good year for snow lovers. I think early on this winter, the temperatures should be average to slightly below average from December to January, but becoming average to maybe even further below average February through March. I think it's going to be a colder and backloaded winter, but again, a lot of this depends on the blocking, which I do have on here as being very likely. I think blocking is going to be the number one factor. I think it's going to tell us the tale of this winter, because it does increase your chance, as I put on here, as having bigger snow events. I think January becomes the transitional period as the La Nina weakens, and I put on here the QBO phase being positive goes against the idea of a polar vortex split, but again, that's not always true, but it's something to consider. I think there's an equal to slightly higher than equal chance that the polar vortex does lean towards the US as opposed to Siberia. So I think our chances of getting a cooler winter are getting stronger by the day. Now the MGO pattern typically does follow the QBO, but that's not always true. So I'm starting to think that maybe the QBO is going to be a poor reliable, not a very reliable indicator this season. Now, I think it is unlikely to see a year like 2015 or 2010, 11, and 95, 96 where we saw massive amounts of snow with a moderate La Nina, but it's still possible. So stay tuned. I have a couple of storms to track, and I'm going to do the best I can to get on live sometime in the next couple of days. Thank you, and I appreciate it. Let's see if I can figure out how to end this video here.